Imagine a world without a sun, a planet adrift in the cold, endless dark of interstellar space. These planets, known as rogue planets, are cosmic wanderers, drifting through the galaxy without a star to call home. These are rogue planets, cosmic nomads untethered from any star, nearly invisible as they wander the galaxy. They travel through the vast expanse of space, unseen and undetected for the most part. Once thought to be orphans ejected from their solar systems, they're now seen as keys to understanding how planetary systems form and evolve. Scientists and astronomers are constantly on the lookout, using advanced technology to track these elusive worlds. Some astronomers believe rogue planets could outnumber the stars in the Milky Way. If true, this would mean there are billions of these lonely wanderers drifting through our galaxy. We find them by detecting the subtle ways their gravity bends the light of distant stars, a technique called gravitational microlensing. This method allows us to spot these hidden planets as they pass in front of stars, creating a temporary brightening effect. Traditionally, we pictured these worlds as frozen and lifeless, but some theories suggest massive rogue planets could keep moons warm enough for liquid water beneath ice. This opens up the possibility of finding life in the most unexpected places. And what if some rogue planets weren't ejected, but born alone, forming in isolation like failed stars? These solitary planets could provide new insights into the processes of planetary formation. For years, this was just speculation. The idea of planets forming in isolation was a topic of much debate and discussion among scientists. Then, astronomers caught a flicker in the darkness, a sign that one of these worlds was being born before our eyes. This discovery has opened up a new chapter in our understanding of the cosmos, revealing the hidden lives of these lonely wanderers. In the constellation Chamaeleon, astronomers focused on a faint object, Cha 1107-7626, a free-floating world 5 to 10 times Jupiter's mass. It was surrounded by a disk of gas and dust, the ingredients for planets and moons. In early 2025, a team led by Victor Almendros Abad began monitoring it with the Very Large Telescope and the James Webb Space Telescope. At first, Cha 1107-7626 seemed quiet, with only a faint hydrogen signature in its disk. But by June, everything changed. The hydrogen signal exploded in intensity. The planet had suddenly come alive, blazing with activity. Astronomers realized they were witnessing a rare, dramatic growth spurt, a planet actively pulling in material from its disk. For the first time, we were watching a rogue planet evolve in real time. We had caught a world in the act of creation. Cha 1107-7626 growth was staggering. It was devouring 6 billion tons of material every second. That's like swallowing the mass of the Great Pyramid of Giza multiple times each second. The planet gained an Earth's worth of mass every 2 months, a record-breaking rate. This wasn't a steady process, but a sudden, violent accretion burst. The disk around the planet became unstable, sending vast amounts of gas and dust spiraling inward. The energy released made the planet glow, turning it from a faint dot into a beacon. For the first time, we could test our theories of planetary growth in a clean, isolated environment. Cha 1107-7626 showed us that planet formation can be far more dynamic and rapid than we ever imagined. The universe's creativity in building worlds had just revealed a new chapter. As Cha 1107-7626 devoured its swirling disk of gas and dust, it grew dramatically brighter, its luminosity surging up to 6 times what it had been before. This was not a subtle change, but a sudden, powerful transformation that caught astronomers by surprise. This intense flare was the unmistakable signature of an accretion burst, a rare and violent event where material rapidly falls onto a forming object, releasing a burst of energy. While accretion bursts have been observed in young stars, witnessing one in a planet was unprecedented, rewriting what we thought we knew about planetary formation. Traditionally, planets are thought to form slowly and quietly within the disks of material that surround young stars, gradually accumulating mass over millions of years. In contrast, stars are born from the dramatic collapse of vast clouds of gas, igniting nuclear fusion in their cores. But Cha 1107-7626 challenges this neat division. It formed in isolation, much like a star, yet it never gained enough mass to ignite fusion and shine on its own. Instead, it sits in the gray area between planets and stars. a cosmic in-betweener. This discovery suggests that some rogue planets, wandering alone through space, are not simply orphans ejected from their systems. Instead, they may be the smallest products of star formation itself, sub-brown dwarfs born in isolation, never tethered to a parent star. The universe, it seems, is far more creative than we imagined. There is more than one way to build a world, and the processes that shape planets and stars can overlap in surprising ways, blurring the boundaries we once thought were clear. Planetary birth can be violent, chaotic, and brilliant, echoing the tumultuous creation of stars. These cosmic events remind us that the formation of worlds is not always a gentle process, but can be marked by drama and intensity. This single observation forces us to rethink the boundaries between planets and stars, and to reconsider how we define these objects. The universe is more complex and wondrous than our categories can contain. The birth of a world isn't always gentle. It can be a cosmic spectacle of light and energy. CHA 11077626 stands as proof that even the smallest objects can have the most dramatic beginnings. What powered this rapid growth? The answer: magnetism. CHA 11077626 has a surprisingly strong magnetic field for its size, acting like a cosmic engine. This field funnels gas and dust from the disk directly onto the planet's poles, a process called magnetospheric accretion. Instead of drifting inward, material is channeled at high speed, creating hotspots and making the planet glow. Magnetospheric accretion was thought to be exclusive to young stars, not planets. This discovery shows even low-mass rogue worlds can generate powerful magnetic fields, shaping their own destinies. Magnetism, it turns out, is a crucial force in planet formation. The unseen power of magnetic fields is rewriting what we know about how worlds are born. The James Webb Space Telescope, humanity's most advanced eye on the cosmos, revealed something extraordinary during the outburst of CHA 11077626, a faint, distant planetary mass object. In a moment of cosmic drama, JWST detected water vapor in the swirling disk of material surrounding this lonely world. Before this sudden burst, the disk showed no trace of water. It was only when the planet flared up, unleashing a surge of energy, that water vapor appeared, almost as if the outburst had awakened something hidden within the dust and gas. The intense heat from the accretion burst vaporized ice-coated dust grains, releasing water molecules into the disk's thin atmosphere. This process, triggered by the planet's own growth, transformed frozen ingredients into a vaporous veil, briefly visible to JWST's sensitive instruments. This marks the first time in history that water vapor has been detected around a planetary mass object during such a dramatic event. It's a breakthrough that pushes the boundaries of what we know about planet formation and the chemistry of young worlds. Water is essential for life as we know it, and witnessing its appearance so early in a planet's formation offers a crucial clue. It suggests that the seeds of habitability may be sown much earlier than previously thought, even in the most isolated corners of the galaxy. The discovery shows that the building blocks of life, water and organic molecules, are present from the very beginning, even for worlds born alone, far from the warmth of a parent star. It hints at a universe where the ingredients for life are more common and accessible than we ever imagined. Thanks to JWST's unprecedented sensitivity and precision, this fleeting detection was possible. The telescope's capabilities have opened a new window into the chemistry of planet birth, allowing us to witness processes that were once invisible. The birth of a planet is not just a physical event, but a chemical one, a cosmic alchemy that can seed new worlds with water and the potential for life, right from the very start. CHA 11077626 behavior challenges our core theories of planet formation. The classic model, core accretion, describes slow growth within a star's disk. But this rogue planet isn't orbiting a star, and its growth is anything but slow. Instead, it formed through gravitational instability, a process usually reserved for stars. This is the strongest evidence yet that planets can form like stars, collapsing rapidly from gas and dust. The line between planet and star is now blurred. It's not just about how they form, but whether they ignite fusion. CHA 11077626 is a star that never lit, a planet born in isolation. The universe has multiple ways to create worlds, some gentle, some explosive. Our textbooks must change. Planet formation is more diverse and dynamic than we ever imagined. The discovery of CHA 11077626's growth spurt stunned astronomers and shattered old assumptions. Rogue planets, once thought dull, are now seen as sites of dramatic cosmic events. We can now witness their fiery births, not just study their ancient remains. This direct observation lets us test theories in real time, revealing the universe's boundless creativity. No one predicted a planet could undergo such a star-like burst. Science thrives on these surprises. Each new discovery forces us to expand our thinking and embrace the unknown. The story of this rogue planet is about curiosity, perseverance, and our quest to understand the cosmos. One distant world has opened a new frontier, giving us more questions and more wonder. CHA 11077626 story is just the beginning. Rogue planets are faint and elusive. Catching one in a growth spurt is rare luck. Are these events common, or is this planet unique? To find out, we need more powerful telescopes and more discoveries. The upcoming Extremely Large Telescope will help us hunt for these hidden worlds, revealing their secrets. As we build a larger sample, we'll piece together the life stories of rogue planets, how they form, grow, and evolve. Each new find adds to the puzzle, showing the galaxy is more dynamic than we thought. By studying these lonely wanderers, we glimpse the processes that built our own Earth. We stand at the dawn of a new era, ready to explore the unseen corners of our galaxy and unlock the mysteries of the cosmos.